Diastereomers and Meso Compounds. Have you got it? This short video quiz assesses your ability to understand the terms diastereomer and Meso Compound, and to identify diasteromeric relationships among structures. The quiz consists of 3 questions. It's meant to be taken after you have studied the material and think you understand it. During the presentation, you'll be asked to pause the video to at least try to solve the problem yourself, and only then to continue. It won't be hardly as effective if you jump to the solution immediately. Okay, here we go. Number 1, in each case, indicate whether the 2 compounds are enantiomers or diastereomers of each other, or if they are 2 representations of the same compound. Pause the video while you answer this question. Okay, we're back. In this first case, we have 1,2-dimethyl cyclohexanes. So they're definitely configurational isomers. They have the same name. One is a cis version and one is the trans version. They're not enantiomers of each other. One is cis and one is trans. So they must be diasteromers. In this next case, we have 2 stereogenic centers, and they're both opposite. So these are enantiomers. Okay, in the next case, looks like we have 2 stereocenters. They look like they're both opposite, but we have to be careful here because if you look carefully, the left side of the molecule is the same as the right side of the molecule. They're both 2,3-dihydroxybutane. So we better look at these pretty carefully and make sure. If you do look carefully, what you'll see is that a rotation 180 degrees around the vertical axis through this point right here turns the one on the left into the one on the right. So these are actually the same compound. Now, we can prove that by quickly determining their R and S descriptors. Okay, so let's do this quickly. On the left, O is number 1. The little chain here is 2, and the methyl group is 3. The H is toward us, so 1, 2, 3, all the way around to 1 is clockwise, but the H is in front, it's S. And on the second one, same deal, 1, 2, 3, coming around, and that is clockwise, so H is in the back, and it's R. We have S and R. Pretty interesting. In the other case, we also have 1, 2, 3, R, and S. But it doesn't matter which end we start with for 2,3-dihydroxybutane. So those really are the same compound. Okay, the last one here. Well, this is just like the one above it, except you notice that the 2 ends are not the same. So here we have, again, an S and R, and here we have the R and the S. But now we have only one numbering option. It has to be 2,3-dihydroxypentane. So these really are different, and they are opposites of each other. So they're enantiomers. Okay? Number 2, in each case, indicate whether the compound is chiral or achiral. Circle all meso compounds. Pause the video while you think about this question. Start it up again when you're ready. Okay, let's see this. First question, chiral or achiral? We're looking for mirror planes. The first one, we have a mirror plane right across here, achiral. Second one, do we have a mirror plane? Not this way, not this way. There's no mirror plane here, so this one is chiral. We can prove it by checking for R and S. In the bottom case, we have 1, 2, 3 going counterclockwise. H is in the back. That's S. And top case, we have 1, 2, 3 going clockwise, but H is in the front. That's also S. So you see, it has to be chiral because there is an R enantiomer of this compound. Okay, third one. You see a plane? Yes, definitely. Right across here, right? So it's achiral. Third one, plane. Right down the middle, like this. Achiral. The next one. Oh, no plane this way. No plane this way. This one is chiral. And let's see what its stereochemical descriptors are here. H is in front. We have 1, 2, 3 around clockwise. H is in front. This is S again. Up at the top, H is in front. We have 1, 2, 3 around. That's R. But it's H is in the front, so it's S again. All right. And in fact, both of those will have reversals, R, the enantiomers. Okay, one on the right, we see a plane. I see a plane right down the middle there. That's achiral. And we're all set. Okay, what about meso compounds? Well, this first one, it has to be achiral. So a meso compound is one of these, one or more of these 4 achiral compounds. Meso or not? Yes, because we have 2 stereocenters. This first one, if we got the descriptor again, it would be 1, 2, 3, counterclockwise, H is in back, S. So this one is S, this one is R. It has no mirror image because the mirror image of the R would be S and the S would be R, and that's going to be the same thing. We just name it from the bottom to the top instead of top to the bottom. Okay, so that's meso. Meso compound is a compound that is achiral, but it has a diastereomer. In other words, there's an SS version of this. In fact, this one right here is its diastereomer. Remember what the definition of meso is. It's an achiral compound that has stereocenters, but also a mirror plane. All right. This one over here, it has a mirror plane, and it definitely has stereocenters. It has 4 stereocenters, so that one's meso. The next one is achiral, and in fact, it has at least 2 or 3 or 4 stereocenters, so this one is meso. And how about this one over here? Well, if you said this was meso, you have to think about what we've got here, because we really do not have any stereogenic centers. It looks like we do, but look, going around this way is the same effectively as going around this way. So those really aren't 4 different things attached to that carbon. There's no stereogenic center in this molecule as we have defined it, and so it's not a meso compound. A little tricky on that last one. All right. Number 3, challenge. In each case, indicate whether the compound is chiral or achiral. Circle all meso compounds. Note that if any conformation is achiral, whether it's a ground state or a transition state or just any state, then the compound is achiral. If you can rotate bonds around in any possible way that would give you a conformation that has a mirror plane, this compound is achiral. Give it a try. Pause the video. Come on back when you think you've got the answers, and I'll let you know what I think. Okay, we're back. All right, well, this first one, let's just draw in some H's here. These are CH3s. I think you can probably see that there's not going to be any mirror plane. You can't draw a mirror plane this way. You can't draw a mirror plane through these this way. There's just no mirror plane here at all. So this one is definitely chiral. How about the second one? Well, I'm going to tell you this is achiral. And the reason is we could draw a Newman projection that's eclipsed. And in that Newman projection, the front part projects onto the back part, meaning we have a mirror image in the plane of the paper. So this one is, in fact, achiral and is a meso compound. Okay, next one. Now, this one is a little tricky because it doesn't really look like we have a mirror plane, does it? But there's two things we can go on here. First of all, I can draw a boat conformation in which both of them are down like this. And there's a mirror plane right through this center of this bond and the center of this bond that causes this compound to be achiral. Now there's another way you think about this. Let's see if we can write the R and the S. Remember, if we get two S's, then it has to be chiral. But if we get an S and an R on a 1,2-dimethylcyclohexane, then it is achiral. Here we go. 1, 2, 3. 1, 2, 3, and to go all the way around like that, the H is in front, so that's S. How about this one over here? Well, it's 1, 2, 3. 1, 2, and then, to get back there, I have to go behind that one. That's S. So that's R. So look, this is the version of 1,2-dimethylcyclohexane that is meso. Now, here's still another way of doing it. Rather than draw the conformation, let's draw the structure as a hexagon. And both of these methyl groups are down and they're next to each other. And now I think it's much easier to see that in fact we have a mirror plane, right? So good trick is to get out of these conformations, use what you know to draw the simple cyclohexane. Remember, both methyls next to each other, both down. There you go, just like that. And that shows that we have a mirror plane. Okay, the next one over here. Well, the deal is that if I rotate this front around, no matter how I rotate it, the front can't align with the back. And that's a big clue that there's no mirror plane here at all. At least it sort of looks like that. Okay, so maybe drawing this again would be helpful. This is a butane, and the methyl groups are sort of together. Do you see how the methyl groups are near each other? So let's just draw like that. Let's just draw it like this. And if this is the front one, then the H is over here, and the bromine is up. And in the other case, the bromine is in the back, and the H is in front. And you can see we can try to draw a mirror plane through here, but it won't work because the bromine is mapping onto the H, and the H is mapping onto the bromine. So this one is chiral. That's pretty tricky, but a few tips there in terms of changing the drawing, seeing it from a slightly different way, can sometimes give us the information we need to get our answer. And going to this simple cyclohexane hexagon-like structure with hashes and wedges can be a very effective way of solving these problems. All right, well, remember, the terms diastereomer and enantiomer are relational, like sister and brother. Of each other is implied. Mary and Jessie are sisters. Okay, but are they sisters of each other? Well, we don't ever say that. We just say if they're sisters, it means they're sisters of each other. Same thing, diasteromers and enantiomer. Two compounds are diasteromers of each other if and only if A, they are configurational isomers of each other, In other words, they're not constitutional isomers. And B, they're not enantiomers of each other. Conformations differ only in rotation around bonds. If any conformation, even a transition state, is achiral, then the compound is achiral. And a meso compound has at least one stereogenic center, but no enantiomer, because they are their own mirror image. Another way of saying this is a meso compound is an achiral compound, that means it has a mirror plane, with a chiral diastereomer. All right, it's a little tricky. Hope that helps, and I hope you've got it.